Hi guys, we're going to be taking a look at section 10.8, equation of a circle. And you're probably wondering why I have a right triangle drawn if we're going to be doing equation of a circle, because there is actually a relationship. And what I'm going to show you now is what kind of a relationship is shared between the equation of a circle and a right triangle. So I'm going to start off with just randomly choosing a point. We're going to start at 0, 0, because why not? And from there, I'm going to use this right triangle to go across the axes. So I'm going to go either 3 over and 4 up, or I'm going to do 4 over and 3 up. So let's count from here. 1, 2, 3. And because I've gone over 3 to the right, I'm going to go up 4. 1, 2, 3, 4. And I'm going to put a dot there. Okay. Now I'm going to do that again, just go in a different direction. Let's say I'm going to go 1, 2, 3, 4, and then 1, 2, 3, and I'm going to put a dot there. Okay, now I'm going to do that a few more times, just do a 3 and a 4. So from here, I'm going to go 1, 2, 3, 1, 2, 3, 4. And I'll do that again. Instead of going 3, I'm going to go 4. 1, 2, 3, 4. 1, 2, 3. Okay, and from here, let's say we go 1, 2, 3. 1, 2, 3, 4. And I'm going to do it a couple of times right here as well. 1, 2, 3, 4. 1, 2, 3. And then here, 1, 2, 3, 4. 1, 2, 3. Okay, so notice I basically kind of did all the possibilities of 4 over 3 up or 3 over 4 up. Now, what do we know about the distance from 0, 0 to any of these points? So like that distance, for example, or this distance, or this distance. What do we know about all of those distances? Well, notice that for any one of them, I can draw a right triangle that is a 3 and a 4. Here, this way I can go 4 down, 3 over. Okay, and by this time, you guys should all know that this is a 3, 4, 5 right triangle. It is a Pythagorean triplet, the 3, 4, 5 triangle, or the triple, the Pythagorean triple. All right, so we figured out that each of these green segments have to be 5 because they make a 3, 4, 5 triangle. So we know that this green segment is 5 no matter which of these points I connect with 0, 0. So the question is, what does this point 0, 0, what is the relationship this point has with all of these other points that I put here? So I hope you were able to figure out that the relationship here is that 0, 0 is the center of a circle with a radius of 5 units. Okay, so you have a center of 0, 0 with a radius of 5 units. Okay, now I want to talk about something else about this circle. In this circle, we have constants and we also have variables. So let's talk about the difference between those two and what are the constants and what are the variables. So first of all, Center 0, 0 and radius of 5 units are constant. Why are they constant? Well, the reason that they are constant is because they don't change. That's what constants are. We don't have to think about what they could be. We know what they are. We know that no matter where we are on this circle, the center is 0, 0, no matter what, and the radius is 5, no matter what. So those numbers we know for a fact when it comes to this circle. Those are constants. Let's talk about variables. What are the variables on this circle? Now, notice as we go around the circle, it has different points, okay, that keep changing as we go around. Now, I'm going to add a few points here. I'm going to add this one because this one is 5 away. It's on the circle, radius of 5, center of 0. And here's another point, radius of 5, center of 0. And you can do that all the way around the circle, okay? And those are not the only points. You can have any point, even though we really don't know where that one is, we can estimate, okay? We can estimate where that one is and so on. But the number of points as you go around the circle is actually infinite. And notice that as we go around the circle, they change. So if I am over here, this point right here is 5, 0. And if I'm over here, this point is 4, 3. And over here, I have point -3, -4. And there's lots of points I can name as I go around. So the amount of points going around the circle is infinite. So because there are an infinite number of points I can name, and because they keep changing, they are called variables. Well, what do we call them then? We can't call them 4, 3 because they're not always going to be 4, 3. We can't call them 5, 0. We have to call them by something that would represent all of the numbers, all of the infinite numbers. So I hope you were able to figure out that because there are so many different numbers, coordinates going all the way around, that we call them X, Y, because we don't know where we're going to be and we don't know what the coordinates on the circle are going to be. There's an infinite amount. So once again, when we look at this circle, we have constants of the center at 0, 0. It's going to be 0, 0 no matter what. And we have a radius of 5 no matter what. Those are the constants, okay? And our variable is xy because that could be any point on the circle. Let's say I wanted to write the equation of this circle. So what we do is we pick a point, and here I've chosen -3, 4. Remember, it could be any point on the circle. And then we have our constants of the center, which is 0, 0, and our radius of 5. And what we can do is we can either use the Pythagorean theorem or we could use the distance formula. Now, remember, the distance formula is the same thing as the Pythagorean theorem. It's just used for coordinate geometry. So I'm going to start with the distance formula. Let's just go over it in case you forgot. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, that's the distance formula. Now, what I want to do is I want to tweak it a little bit. So what I'm going to do is I'm going to square both sides. So I have d squared, and I'm also going to square the other side. And that's going to give me a new formula which is d squared is equal to square root and the squared are going to cancel each other out. So this and this are going to cancel each other out. And I have x2 minus x1 squared plus y2 minus y1 squared. Okay, and we're going to use this to write the equation of a circle. But first, I'm going to tweak it one more time. If we look at our chosen segment, it's 5. So 5 represents the distance, but 5 is also the radius of this circle. So instead of d squared, I'm going to write r squared instead. So I'm going to erase this d so I don't have to rewrite everything. And I'm just going to put an r there instead. Let's put in our numbers. So I've got 5 squared is equal to, now I'm going to take my -3 and subtract 0. Okay, those are my x's, -3 and 0. And my y's are +4 and 0. So again, I have radius of 5, that's squared, and then I have -3 minus 0, those are my x's, and 4 minus 0, those are my y's, and I'm squaring everything because this is the Pythagorean theorem or the distance formula. Okay, I'm going to stop right here because all we're going to end up with is 5 squared equals 5 squared. Right? But we need to derive the formula. So this is the example just for this particular segment. So I'm going to go on to another segment. So here we are again, and I'm selecting a different segment. The radius is still 5. The center is still 0, 0. But now I have a different point, 5, 0. So I'm going to write our new equation. We still have the 5 squared equals. Now this time we have 5 minus 0. That's this 5 and this 0. Okay. Plus 0 minus 0. Oops, I forgot the squared there. That's this 0 minus this 0. Okay. I'm going to do this again. All right, here we are, and I have selected another segment. And once again, our constant still 0, 0, still radius of 5, but this time we have -4, -3 as the point we have selected on the circle. And I'm going to write the equation again. So again, 5 squared equals, this time we have -4 minus 0 squared plus -3 minus 0 squared. All right, so I'm going to stop here and I'm going to take a look at the similarities and the differences in this equation. So notice that no matter what, we have a 5 here. Why is that a 5? Well, once again, in this circle, the radius is always 5, no matter what. Now, what else is constantly the same? If you look over here, this 0 is constantly the same, and this 0 is constantly the same. What does that 0 represent, this 0, 0? Well, that represents the center, which is always 0, 0 in this case. Okay, now the only thing that keeps changing is this part right here. Those are not the same. These are not the same. These are not the same. Now, why are those numbers not the same every time? Well, they are not the same because they are variables, right? As we go around the circle, they keep changing. So since 5 is our radius, that's going to stay the same. So 5 squared is equal to 25. That's going to be 25 no matter where I am on the circle. What else stays constant? Well, our 0, 0, our center, is still going to be 0, 0 no matter where we go. So I'm going to have 0 here, minus 0 there, squared, and minus 0 here, squared. Now, the -4, -3 was just a sample. That was just this point. So we could have -4, -3. We could have this 5, 0. That point could be anything. So since that's anything, that's where the variables come in. So instead of all of these numbers, which could change, we put x. And instead of all of these numbers that are going to change, we put y, because those numbers are changing, and therefore that's where the variables come in. So the equation of this circle is 25 equals x minus 0 squared plus y minus 0 squared. Now, we don't really need to write minus 0. So the way we would simplify that is just 25 is equal to x squared plus y squared. And if you wanted to make it prettier and make it look more like the Pythagorean theorem, you could turn it around and say x squared plus y squared equals 25. So looking at this equation, you would know that since there's nothing being subtracted over here, that your center x has to be at 0. And because nothing is being subtracted here, your center y coordinate is also 0. So if you see x squared, y squared, you automatically know that you have a center at 0, 0. Now, this part right here, we know that that is the radius squared. So if 25 is the radius squared, you would know if you saw the 25 that the radius is equal to square root of 25 or 5, because this right here is always going to be the radius squared. All right. So that is one example of how to write the equation of a circle. So now it's going to get easier because we're not going to keep deriving it. But I hope that showing you all of this has helped you understand where the circle equation comes from. Let's do a few exercises. So in the first two exercises, we are given the equation of a circle, and we need to find the center and the radius. All right, so once again, since you do not see any subtraction going on here or any subtraction going on here, you know that the original equation had x minus 0 squared plus y minus 0 squared, right? We know that it was that. So the center is 0, 0, okay? And since this is the radius squared, what squared is 36? Or what is the square root of 36? So the radius is square root of 36. So what's that? The square root of 36 is 6. So the center is 0, 0, and the radius is 6. All right, moving on to the next one. We have the same sort of equation as above, x squared plus y squared. So we know that the center is 0, 0. Now what's the radius? The radius has to be the square root of 10. And there's really no way to simplify that. So our answer is center is 0, 0, and radius is square root of 10. Now you can also find decimal equivalent. And you can say that your square root is approximately, let's say, 3.16. So your radius is around 3 units. All right, The next one asks you the reverse question. It's giving you the center and the radius is 4. So to begin, if you know that it's just x squared plus y squared, you can just write that. Or you can say, okay, x minus 0 squared plus y minus 0 squared is equal to 4 squared. That's the Pythagorean theorem. And to simplify that, x squared plus y squared equals 16. That's the equation of that circle. All right. The next one, again, center is 0, 0. So I'm going to skip that beginning part, and I'm just going to go directly to x squared plus y squared. And the second part, the radius is square root of 5. So we have square root of 5 squared, all right? And square root of 5 squared simplifies to just 5. So the answer for this one is x squared plus y squared equals 5. Here is an example of a circle that is not at the origin or not at 0, 0. The center is somewhere else. So we're going to take a look at how to write the equation of a circle when the center is not at the origin or not at 0, 0. The first thing we're going to take a look at is the general formula, which is right here. This is the general formula of a circle. So let me just tell you about what each part represents. The center is HK, okay? The radius is R, and the X and the Y are all the points around the circle, okay? And those could be any point you choose. So those are infinite and those are variables, which is why we're calling them X and Y. How do we write the equation of this circle? Now, remember that our constants are the only parts that we can put in the equation because they never change. What are our constants? Well, our constants are the center, and in this case, the center is -2, 5. And our other constant is the radius, and in this case, the radius is 7. So what we're going to fill in is we're going to fill in -2 and 5 because our center is HK. And for the radius, we're going to fill in 7. All right, and everything else is going to be a variable. The X is a variable, the Y is a variable. So here I have X minus -2 squared plus y minus 5 squared equals 7 squared. Now notice that right over here, we have a minus a negative. So that actually becomes x plus 2 squared plus y minus 5 squared equals 49. And that is the equation of this circle. Now, let's just take a look at a few things here. Okay, notice that our center is -2, 5, but yet here we have +2. So the center is at -2, but here we have +2. And also the center is at +5, but here we have -5. So notice that from the equation, you have to change the signs to get the center because the original equation is the distance formula and we're subtracting. And when you subtract a negative, you get a positive. And when you subtract a positive, you get negative. Okay, so just keep that in mind. Okay, let's do a few exercises. Find the center and radius of each circle. So here I have this equation. Now, remember, we are using the distance formula, and the distance formula, x minus h squared plus y minus k squared equals radius squared. So the actual center is hk. So if there's a minus there, then we just take the h. If there's a plus there, then it's actually a negative that the h is. So if we have -1, the center is +1. And if we have +3, then we have -3. So notice how it's opposite. Okay, what's the radius? The radius is square root of 100 or 10. All right, let's take a look at the next one. Now here we have x plus 4, which means that the x coordinate is -4. And here we have y squared. Now y squared actually means that we were subtracting 0. So that means that the y coordinate is 0. Now for the radius, we have square root of 60. Now there's two ways to write this. One way is to simplify square root of 60. To simplify square root of 60, we would first break it up. Let's say we could do 6 times 10. The 6 and 10 is 2 and 3, and the 10 is 2 and 5. So this is square root of 2 times square root of 3 times square root of 2 times square root of 5. And notice here we have square root of 2 times 2. I'm sorry, square root of 2 times square root of 2, which is just 2. And then square root of 3 times square root of 5 is square root of 15. So this is equal to 2 square root of 15. Another way you can write the radius is in decimal form, and it's approximately 7.75. So that's the approximate length of the radius. Okay, let's move on. Write the equation of each circle. So we have a center at 6, 0. So that means I have x minus 6 squared plus, now because that part is 0, you can just say y squared, because subtracting 0, you're going to simplify to just y, equals 9 squared. 9 squared is 81. So that's your equation. Okay, let's move on. Center, -5, -1. So x minus -5 squared plus y minus -1 squared equals 2 square root of 3 squared. Okay, first of all, over here we have x plus 5 squared plus y plus 1 squared equals, now I'm going to do this on the side, I'll do it over here on the left side, 2 square root of 3 times 2 square root of 3. 2 times 2 is 4. Square root of 3 times square root of 3 is square root of 9. That equals to 4 times 3, which is 12. So that is the equation of the circle. Just to recap, if you have the equation x squared plus y squared equals whatever, you are going to have a center at 0, 0 always, and the circle will be centered at 0, 0. So let me just copy and paste that equation. I'm going to change what it's equal to let's say 50. So notice again, circle is smaller, still centered at 0, 0. X squared plus y squared equals 9. Notice that the radius is 3. That's the square root of 9. Center is 0, 0. And let's say I did 4. Notice that the radius is 2. And again, center is at 0, 0. We could even go a little smaller. I can make this a 1. A square root of 1 is 1. So we have a radius of 1, still centered at 0, 0. These are concentric circles, which means that they're all circles with the same center. Okay, so again, x squared plus y squared, you are always going to have a center at 0, 0. So here we have the equation x minus 2 squared plus y plus 5 squared equals 81. And because we have a minus 2 there, I know that my center has a coordinate, x coordinate at 2. Because that's plus 5, I know I have a y coordinate of minus 5. And as you can see in this circle, 2, negative 5 is right here, and that is the center of this circle. Also, the radius is square root of 81, and if you count here, you'll notice that square root of 81 is 9, radius is 9. Let's say I change this to a plus, and I make this a minus. You'll notice nothing happened to the size of the circle because the radius is still 9. However, the center has now moved. The center is now negative 2, positive 5. And if you look closely, that's exactly where that center is. Now I'm going to change this to a plus 5. And you'll notice now the center is at negative 2, negative 5. Okay? So I hope this all made sense and you have a better understanding of where the formula comes from and why it's the formula of a circle. So once again, the general formula of a circle is x minus h squared plus y minus k squared equals r squared, where k is the center, r is the radius, and all of this, these are constants. Okay, and then the points that are on the circle, those are variables. And because they are variables and because they are infinite, we just call those points x, y. So any of these points on the circle are x, y. And those are all the parts of the formula for a circle. I hope you enjoy this and this made sense to you. Please let me know in the comments.